All right, let's talk about one of the smartest, most powerful ideas in AI today, transfer learning. Seriously, this concept is a total game changer for how we build intelligent systems.
I mean, think about it. Why would you build an AI from scratch when you could just borrow its brain? What if you could skip the whole learning from zero part and just give it a head start? Let it learn from an expert. That right there is the whole idea behind transfer learning. But okay, before we get into the how, we really need to understand the why. And the why is that training a modern AI from the ground up, it is a massive, massive task. A mountain of a task, really. Just to put this in perspective for you, a sophisticated model that recognizes images, it might have up to 10 million different parameters that need to be tuned. Imagine trying to perfectly adjust 10 million tiny little knobs all at once to get the right answer. It's just a staggering amount of complexity to deal with. And here's the kicker. When you have that many knobs to turn, but maybe not a ton of data to learn from, you get this huge problem called overfitting. Basically, the AI stops actually learning the rules and just memorizes the answers. It's like it aces the practice test because it saw all the questions before, but then it completely bombs the final exam because it has no idea how to handle anything new. So, what's the fix for this massive problem? Well, it's actually pretty elegant and it's super effective. We just stop reinventing the wheel every single time. And that's the heart of transfer learning. It's all about reusing a model that's already been trained on one task and using it as a starting point for another, similar task. The analogy I love is this. Would you rather teach a baby what a car is by first explaining physics and light and shapes? Or would you just show a picture of a car to an adult who already gets all that stuff? Transfer learning is like teaching the adult. We're leveraging knowledge that's already there. Okay, so how does this knowledge transfer actually work under the hood? To get it, we've got to peek inside the brain of a common AI for image stuff, which is called a convolutional neural network, or CNN for short. So a CNN really has two main parts. You've got the first part, which does something called feature extraction. This is basically where the AI learns how to see. And then there's the second part, for classification. This is where it learns how to decide what it's seen. So what are these features it's pulling out? Well, they're kind of the basic building blocks of any picture. The AI doesn't see a car right away. Nope. It sees edges, corners, textures, little points of interest, all these little clues that it then uses to piece together the bigger picture. Here's a great way to visualize it. On the left, that's what we see, right? A normal photo. But on the right, that's what the AI's feature extractor sees. It's like a map of all the important patterns it's identified. It's a totally different way of looking at the world, but it's super effective for a machine. So the key takeaway here is that the two parts do very different jobs. The feature extraction part does all the heavy lifting. It finds the what. The lines, the curves, the textures. Then the classification block comes in, looks at that map of features and makes the final call. It decides if all those bits and pieces actually add up to a car or a dog or whatever it's looking for. All right, so now we get the two parts of the AI brain. This is where it gets really cool because we can look at the three main strategies developers use to pull off transfer learning. It's a pretty simple playbook, but it is incredibly powerful. So what's in the playbook? Basically three main plays. First, you can just take a huge pre-trained model and use it straight out of the box. Second, you can borrow just its eyes, that feature extractor part. Or third, you can do some really targeted retraining on just the final, most specialized layers. Let's dive into each one. Strategy number one is the easiest. Big tech companies pour tons of resources into training these enormous general-purpose models on insane amounts of data. Think of models like BERT for understanding language or YOLO for spotting objects in an image. They're so good that a lot of the time you can just grab one and use it for your own project and get amazing results right away. Okay, strategy two is where things get really clever. What we do here is take a pre-trained model and basically perform some surgery. We chop off the final layers, its original decision-making brain, but we keep the really powerful part, its pre-trained eyes, that feature extractor. Then we just snap on our own little classifier at the end and only train that small new piece on our specific data. It's brilliant. And finally, strategy three is kind of a mix of both. We freeze the first few layers of the network, the ones that learned all the really basic stuff like how to see edges and colors. We don't touch those, but we let the later layers, the more specialized ones, get retrained or fine-tuned on our new data. This way, you're adapting its expertise to your problem without making it forget everything it already knows. So you might be thinking this is just a neat trick for developers, but it's so much more than that. Transfer learning has these huge real-world consequences for how AI gets built and, just as importantly, who gets to build it. Let's talk about why this all matters.
Okay, so what's the bottom line? Why is this such a big deal? Well, for starters, it helps solve the "I don't have enough data" problem, which is a roadblock for pretty much everyone who isn't a tech giant. It also slashes training time from like weeks down to maybe just a few hours. And this is a big one. It means you don't need these super expensive, power-guzzling computer setups. It makes AI development way more accessible for everybody. And that last point about the hardware, that's not just about money. The environmental cost of training these giant models from scratch is just enormous. There was this study in the MIT Technology Review that found that training just one large AI model can emit as much carbon as 5 cars do in their entire lifetimes. I mean, that's just wild.
Transfer learning is changing that. By recycling and reusing all that hard computational work, it's making AI not just faster, not just cheaper, but also way, way more sustainable. And that kind of leaves us with this really fascinating final thought, doesn't it? We figured out how to get AI models to pass knowledge between each other, almost like a teacher passing lessons to a student. So the really big question now is, what happens next? What amazing things are going to happen when AIs start teaching each other?